Buenas tardes, estudiantes. Hoje nós falamos. No, it's switched to Portuguese because I don't know how to speak Spanish, but that's okay. So check it out. Welcome back, everybody. I don't know how to say geometers in Spanish. I'm guessing geometrica is probably geometry. Yep. I don't know how to make the ist noise because I don't speak the language. But check it out. We run through, and yesterday we saw two ways of factoring. We saw the greatest common factor, which, as I look at these three, is there a greatest common factor? Nope, bummer. Okay, no, so Elijah said something, if you didn't catch it, he said not other than one. One will always be a common factor, but it's a meaningless common factor. We never care if it's just a one right here. Okay, so then we're just going to do the same thing. Now, I made a comment a second ago that I'm going to write a little bit more algebra-looking stuff. Every single thing that we deal with as a trinomial, especially if it's x squared, will have this form. Ax squared plus bx plus c. Now, this is just a general form. You guys probably recognize seeing something like this last year, where this a, b, and c are our main focus right now. Okay, in this expression, what is the value of a? Okay, 6. Real quickly, does anybody in here have an allergy, a food allergy? Peanuts, coconut, almonds. Who in here is allergic to what? Okay, so this is going to make this much easier. Who just told me what A was? Who gave me A just now? Was it really you? Who was it? All right. If you want to trade candy, we can, but I'm just going to be chucking these things out, just so you know. Sweet. All right. So A is 6. I'm cool with that. What is C? All right. Oh, you're wrong. No, I want it. I'll put it up here. I'll save it. This is my second favorite candy. Do you like peanuts? Okay. So C is -1. I'm going to multiply them. I will throw out candy as I see fit. Thank you. Okay. 6 is close. -6. Really, you get one. Okay. I might have bought too much candy. All right. Interesting that a 10-cent piece of candy gets this much motivation. Cool. Excellent. Okay. I need to find factors of -6 that add up to what number again? Why did you raise your hand? Why did you raise your hand? Okay, so chill out. Just so you guys know, everybody will get candy today. Like, everybody's going to get some candy. So, like, we'll get there. I need two numbers that multiply to be -6. So let me finish the question first. I need two numbers that multiply to be -6, but they add up to what? -1. Now, these can be hard to find. With this, it's not a particularly hard one to find. However, when we get bigger numbers, which is coming up soon, I want to think about all the ways that we can get to 6. We could do 1 times 6. One of these has to be negative. Why 1? I disagree. So, I actually disagree. These things have to add up to what number? -1. If they have to add up to -1, the bigger number better be negative. Now, if it wasn't 1 and 6, that's a bummer. Klein, you have a different suggestion. 2 and -3 is another way to get to 6. If I multiply, I'd get -6. What do these add up to? -1. This is exactly what I need to rewrite this. Now, to use grouping, we are going to take this 3-nomial, our trinomial, and we're going to rewrite it as a 4-nomial. Instead of -1x, Liam, what am I going to write? Instead of -x, sorry. Yep. -3x minus 2x. So careful, I don't quite agree. -3x plus 2x. Okay, good. Now, here's the weirdest part of this. I never understood this when I was your age, and my teacher never hit on it. The order here doesn't matter. Not at all. If I get to choose, I'm always going to write the negative number first, but realistically, it doesn't matter which one I write first. So here we are. I'm going to rewrite the expression. 6x squared. I'm going to leave a blank space in here, and instead of -x, we're going to use these magic numbers. Sorry? So we can use the minus first. I'm fine with that. -3x plus 2x. Could I have done 2x and -3x? Cool. The order doesn't matter. You're good if you just set them there. Went better?
I hope so.
Cool. All right. Now, why would I ever take the time to write this trinomial instead of a fournomial? So easier, not necessarily. I'm going to put it into two groups. Like I'm going to use the associative property, which says I can put parentheses around stuff as long as it doesn't magically change. By getting an even number here, we have two groups right here. Okay, if you can get to here and you're okay with everything that we've done up to this point, we've done the hardest part of the problem. Do we have any questions before we continue on? Okay, so let's keep kicking. Out of this first group, is there a common factor?
Yes.
So 3 goes into both of them, 6 and 3, and they both have an x. Okay, 3x leaves what behind?
2x
So
minus
2x,
x.
because now if we distribute, we can double check, right? Is this 6x squared? Good. And minus 1. Okay, now people are getting like really into the timing thing, which is not really what I was expecting out of this prize, but I might lean into this. We'll see. If you're struggling to figure out what's left behind, we factor it out, but the alternative, the synonym that means the same thing, and it's just a different way to think about it. If you recognize that a 3 and an x go into both of them, when you're trying to figure out what's left behind, think about dividing. People really regularly say this just disappears, right? Because you've taken it out and now it's gone. It's not. It divides so that when we distribute back through, we're good. Now, this is a kind of unique one. I know that I'm right when I'm factoring if whatever's inside these two groups winds up matching. What could I possibly take out of this group to ensure that I leave behind a 2x minus 1? This is the only situation that you would ever factor out a GCF of 1. It is already 2x minus 1. The only thing that we can divide by or factor out without changing it is a 1. Okay, at this point in the problem, Yash, we made some eye contact. How do I know I'm right? So to Yash, like notice, yesterday I underlined these and they happen to be the same, right? Are these the same? I'm convinced that we are correct at this point in time. What's one of my two factors?
3x plus 1.
So 3x plus 1, the stuff that's not in the parentheses. 3x plus 1. And the other factor? 2x minus 1. Now, it does show up twice, but remember, this just comes out of that idea of rewriting distribution or FOIL in a wonky way that we can get here. The hardest part of this problem by far is finding these two numbers. Okay, how's it feeling with the factoring stuff? All right, I'm going to give you guys 3 more to do for me real quick. The numbers are going to get gradually bigger. Today we are just factoring. Tomorrow we'll start chapter 4 stuff. But because this is such a, for lack of a better word, weak skill when we get to Algebra 2, especially if you have a year off between, it's worth our time to do it now. We'll probably do it again in December. We'll do it again in April or May. Like, we'll do this throughout the year. Okay, now, as we look at this, I want you guys, I'm going to pause the video, but I'm going to get you 3 ones with progressively bigger numbers. Okay, so for A, just kidding, this is C, right? Yeah. Okay, now C, D, and E that we write here, we're going to look at here in just a minute. We're going to see if we can't make a connection. Yes, miss? If you want to come back to your notes, I'm cool with that. Yep. Okay, and you don't even have to do example B there. Just skip it. Just say bell ringer. Like, cool. All right, so for C, Ronaldo, anybody who's in Algebra 2, we are doing this without a shortcut because the goal of the next few minutes is to discover the shortcut. Okay, so here we go. I want us, cool, yep, to do the following. This time on C, and we're going to have 3 of them here. X squared, I'll write that like a normal handwriting. X squared plus 13x plus 42. All right, I'm going to pause it here. I want you guys to start working. We will check with C and D and E here in just a couple minutes. Cool. You guys can get started on C. Once you and your neighbors are comfortable with C or Charlie here, then you will move on to Delta. Once you and your neighbors agree with Delta, we'll move on to Echo. We'll come back together as a whole class to see that there's a really handy connection here. Cool. I'll give you guys a minute to start with Charlie, and I'll get a couple more problems up here. So throughout this, here's the deal. I think I see bits and pieces of people remembering a bunch of stuff. This feels, it's been a while since you've done this. Does everybody in here recall doing this last year?
Yeah.
Okay, do I do it the same as Russell? Pretty close. Do I do it the same as Jarvis? Okay, yeah, me, Russell, and Jarvis do like the exact same thing. Okay, now as we're looking at this, I gave you this hint. Is one of these the pair of magic numbers I need? 6 and 7. What am I going to use these to replace? Okay, so if you think you see the shortcut, I'm going to encourage, let's just do the grouping for a couple more times. We'll see the shortcut really clearly when they're all up. So I have x squared, and then I'm going to do plus, does the order matter? Nope. I'll do 6 first, plus 7x, and then finally, what's still there?
42.
Plus 42. Now, this is the exact same expression. This is still 13x. We've just written it differently, and we've written it in a way that's going to allow us to break it down into its smaller pieces. I'm going to introduce parentheses. Do these parentheses change anything about the problem? Nope. If you wanted to distribute whatever is here, we don't even write it, but what's a number that we could write here? Not an x. It could be a 1, and then if we distribute it, nothing changes. So nothing different about this. In this one, we now simply need to find the greatest common factor. X goes into both of them. What is left behind if I divided x squared by x? X, and if I took this and divided it by the x that I've taken out, it'd be a 6. Now, there's a bunch of different ways that you can try to logic through that. They're all going to do the same thing. I like to think about factoring like dividing. Or if you realize they both have an x, the question could be, if I didn't know that this was an x right here, what do I multiply this x by to get x squared? And the answer is still x. It's the same thing. Okay, plus, is there a GCF of this group? What goes into 7 and 42? 7. When I take out a 7, what's left behind? So 7x divided by 7 is x, and 42 divided by 7 is 6. Do I know that I'm correct at this point? How? They match. One of my factors is what? X plus 6 is the whole factor. And the other factor? X and plus 7. X plus 7. And we're done. This is completely factored. Now, the extra extension that we're not doing right now that you guys saw in algebra was you set it equal to 0 is what wound up happening. Okay, we're not doing that here, but you have. Okay, on this one, I'm going to work through it with a little bit of help from you guys. We're going to go a little bit quicker. Okay, what's the number out in front? 1 times negative 35. Okay, so again, this, some of you are going to be able to find these really quickly. Some of you are going to take a while to find it. It's okay. I want you to think through it in the same way every time. 1 and 35, if it has to be negative, one of these needs to be negative. Now, the fact that they add up to a negative says the bigger number. Do these add up to negative 2, though? Bummer. Does 2 go into 35? Does 3? Does 4? Does 5? 5 and negative 7. Coincidentally, these add up to negative 2. Okay, so I'm going to rewrite the grouping. Do you want me to change colors? Okay, so when I rewrite this, I'm going to show you guys, I typically do the minus first if there's only one, but we don't have to. If I don't do the minus first, it's okay. I'm going to leave a little gap there. There's something that I don't like about this. We should include the plus sign here, and I know it seems weird to say plus and negative, but the reason that we do that is if I do the grouping right now, all of a sudden we have a very different operation happening. These things are multiplying. We avoid that by saying, oh, subtracting 7 is really just adding a negative 7. Okay, once we're here, this is the hardest part. What could I possibly take out of this one, Rylinho? Good. What would it leave behind, Machuca? Love it. Okay, what honor could I take out of this one to leave behind an x plus 5? So no, that's okay if you're not that far. There's an easier way to ask the same question. What would I need to divide this by right here to make it be a single one positive x? 7 or negative 7? If we factor out a negative 7, it's going to leave behind, as long as we haven't messed up, x plus 5. And I can double check that. Negative 7x minus 35. Yep, I'm convinced. Okay, at this point, can I see my two factors? Tristan, what's one of my two factors? So x minus 7, love it. And Henning, the other one? Perfect. Awesome. Okay, and we're done. Did you guys just hear a spooky ghost out there? Okay. Okay, notice the numbers get bigger. Nothing has to change. I don't know a whole lot of factors in negative 96, but I have a feeling that it's probably not going to be 1 in 96. But that's where my head starts. Which one of these should be negative? Are you sure? Okay, so if you've noticed, what's up? It should be the negative 1. Because, and if you're wondering why, and because naturally, oftentimes we'll get the bigger number is negative. All I care about is if I added these up, is the number positive or negative? And this is yep, that's how we're making that determination. Okay, so it's not these. 2 goes into 96, 2 and 48. Do those add up to 4? But notice what's happening. And if you haven't ever noticed it or thought about it, these add up to 95, right? That's way off. What do these add up to? Are we getting closer? Okay, 3 does not go into 96. Does 4? 3 does? 3 times 32. Okay, negative 3 and 32. Do those add up to 4? No, but they add up to 28. Are we getting closer again? Like we're getting continuously closer. Does 4 go into it? 4 times 24? Okay, those add up to positive 4. True or false? Okay, yep, it's false. Now, some of you can find these numbers quickly, right? And you might be just dragging along. In my head, legitimately, this is what I think every time. Does 5 go into 96? Does 6 go into 96? Certainly does. 6 times what? 16. What do those add up to? Notice we are getting really close. Okay, there's probably one more. Does 8 go into it? How many times? Is that my magic? Okay, here's my challenge. Could we rewrite this with grouping? Like, could we do the exact same thing we've been doing? Okay, do I need to? Okay, so we'll do it one more time, and then the answer is no. We don't really need to do this, but we'll make sure we can see it. So if I rewrite this, x squared minus 8x plus 12x, here's my magic numbers, replacing 4, minus 96. Gian, what would you take out of this first group? So a 1 is true, that's correct. 1x. Okay, Sevilla, what gets left behind if I factored an x out? X minus 8, nice job. Okay, my only job here, assuming that I've done things right, and we shouldn't just write it thinking that we have, but maybe this is the easier way. What would you divide this by to make it a positive 1x? So if I try to factor out a 12, let's just see if it works. That's an x. What's 12 times 8? 12 times 8 is 96, which means it works. Okay, at this point, can I see my two factors? Okay, one of them is what?
X plus 12.
X plus 12. Really, the look on your face just now, couldn't read. Like, I'm not offended or anything if it was supposed to be. Did I lose you?
Oh no, it's because I made it.
Okay, no, you're good. Like, your face was fine, just for the record. But I just wanted to see, like, if it's a look of pure confusion, that'd be a good thing for me to know. If not, cool. Okay, this worked out, right? Now, there's something awesome happening here. And shortcuts galore. Should we be more efficient when given the opportunity? Absolutely. Now, if I talk about a coefficient, do you guys know what I'm referring to? So easy to talk about. A coefficient is just the number in front of a variable. What's the biggest power of x in any of these three? So x squared. That's it, right? So this is what I would call the leading term. It's the biggest one. You don't have to add these. In fact, we never really truly have it. But what's a number in front of x squared that we just decided not to write? 1. What was the number in front of this x squared that we just didn't write? And what was the number in front of this x squared that we just didn't write? Okay. We have a huge connection about to happen. We're going to make a quick comment, and you guys are going to help me finish it. Underneath, and it can be underneath all three of these, we're going to define for ourselves, and we're still in the grouping category, we're going to say if the leading coefficient, which you will never see me write this again, this is the number in front of x squared. If the leading coefficient, any guess on what I might call this with shorthand? LC. If the leading coefficient in each of these, is 1. Is 1. I don't know why there's a comma there. If the leading coefficient is 1, then we have a shortcut. And you guys are going to help me see this shortcut right now. And we're going to exclaim that because that's pretty good news. Grouping will always work so long as it's something that can be factored. But if we get the opportunity to take a faster route through it, we should probably just seize it. Okay, I want to notice something here. And I'm going to come back over here. I'll just grab my tablet and we can walk around and talk about it. There is a really convenient connection that I'm going to help us identify. On problem C, do you guys have all the work done on your papers? All right, so whether you're looking at my board or the paper shouldn't really matter. But on problem C, what were the two magic numbers that we found? 6 and 7. Now, I'm just going to make this really bold. Notice, do you guys agree it was a positive 6 and a positive 7? Okay, so check it. When I got to my factors at the bottom, I know that the first terms, if we were to FOIL, it'd be x times x, has to be for x squared. But notice the two numbers that we found. A positive 6 and a positive, hey, those were the same. Oh, that just must be a coincidence. What were the magic numbers on D? Positive 5 and negative 7. Well, holy cow, here's a positive 5 and a negative 7. My magic numbers here, negative 8 and 12. Negative 8 and positive 12. Okay. If and only if we have a leading coefficient of 1, which is what we have on each of these, and we can find those numbers, we have a huge shortcut, which is going to save a ton of time anytime you're factoring. Okay, we're going to try the shortcut right here. We have enough space. We're going to do one more problem like this, trying to use the shortcut. Okay, so let's work one out here. Any number suggestion? So let's see here. We'll have x squared plus 11x plus 30. Now, I did not just ignore your 5 and 6, just for the record. Okay, as we run through, is there a GCF between these three? Nothing that goes into all three of them. Okay, we have a trinomial, right? Okay, is the leading coefficient 1? Okay, if you're looking at that and you didn't answer because you're unsure, the number in front of the x squared right here is definitely a 1. We just don't write it. Okay, I still am going to start the same way. What's 1 times 30? 30. Don't shout it out, but I want you guys, whether it's on paper or in your head, find me my two magic numbers. Don't shout it. I want you to check with your neighbors once you think you found it, quietly, to see if we can all agree. I'm going to start listing all of them in case you struggle. Okay, on the count of 3, we're all going to say it. 1, 2, 3. 5 and 6. Notice, I listed out all of them here. These two do the trick. Now, we could go through and rewrite our trinomial as a four-nomial and do the grouping stuff as always. But because we noticed this wonderful pattern, there's an easier way to do it. I know that each of my two factors begin with just a single x. This is because when I multiply them, I'm just going to get x squared, which is what I need. What are the two magic numbers with the signs? So 5, I need a sign on it. Is it a plus 5 or a minus 5? It's a plus or a positive 5. And the other number? Plus 6. And look at that. There's a shortcut for these. Now, the shortcut only if we have what? A 1 as a leading coefficient. Okay, for this, you guys have certainly seen this before. Like, I know you have. Whether or not you remember it might be a different question. Do you feel like you could factor a few random problems? Okay, so I want you guys, I have no issue if it's, since we're just reviewing stuff, before I move on, questions about using the shortcut? It will not be the same thing if you have a negative. Do you mean negative here? Yeah, let's do one more here like this. So one more example, and that's a good question. Let's say it's, I'm going to give us a curveball here. Okay, let's do, I got to think this out. What's your favorite number, Relly? 7? Okay, so I'm going to do 2x squared plus 14x plus 12. We'll get there. We'll get there. Okay, I'm trying to trick you. And if you didn't catch, Adeline noticed right away. She said, hey, that's not going to work. There's a 2. What was the only other type of factoring that we looked at? Oh, I heard 2 different things. I heard GCF and I heard something else. So I would say that's still grouping, but I'm cool with that. Okay, GCF. What does GCF stand for? Every problem that you ever do with factoring stuff, this should be your first stop. Because right now it doesn't work. You could group it. You would find factors of 2 times 12, which is 24. And you would have to do the same thing. Or we can look at this first and just recognize something. What goes into all 3 of these? If I take a 2 out, let's look and see what's left inside these parentheses. X squared plus 7x plus 6. Now, just like when we factor with numbers, we don't leave the ones behind once we find them. This 2, can I just leave it behind? Or is it going to come along for the rest of the ride? It's going to come along with, it's not going to wind up impacting anything, but I'm not going to leave it behind. Now, inside of this set of parentheses, if we forget about the 2, what's the number in front of the x squared? Okay, so here we go. We're just doing the same thing. Can you tell me 2 numbers that multiply to be 6? So what do those add up to, though? So that doesn't work, because what do they have to add up to for us? 6. What? 7. Sorry. 3 and 2 multiply to be 6, but they add up to 5. Okay, before we get to 3 and 2, what should have been the first numbers we checked? Okay, do those add up to 7? Okay, the fact that that happens, and now inside of our parentheses we have a leading coefficient of 1, I'm just going to move that down a little bit. If I write the 2 out front, is there a shortcut for what's inside the parentheses? One of them gets an x, and what's the magic number? Plus 1. And the order doesn't matter. You could write x plus 6 first. What's the other one? X. Boom. And we have it. We can factor these pretty well, pretty easily. Now, last year, when you learned factoring, I assume you learned it similar to this. I think me and Russell teach about the same. A little bit different. Obviously, we're different people. If you felt like you struggled with Mr. Russell or Ms. Jarvis or whoever your teacher was last year, that's fair. I think that if you're looking at it thinking, gosh, I wish we'd learned it this way, I think you did, just for the record. Things are always easier if you're coming back to it. I think all of you could factor last year, for the most part, I assume. And it was probably hard. That's okay. We're just reminding ourselves of how to do it. Okay, we are only going to do a few more here. And last little section of this, tomorrow we're going to start chapter 4. I have a few more that I would like you to factor for me. Okay, you can use grouping or the shortcut, depending on whichever one it is. So for this, bless you, example, and I'm not going to name this example yet. We'll see what it's named after we do it. Okay, I'm going to write something wonky here that is going to look like off, but we'll see why I'm doing it momentarily. Let's say I wanted x squared, and this is the part that you're going to think is dumb, but you should write it for now, plus 0x minus 9. Now, I'm writing it this way only so we can use techniques that we have. Do you guys agree that I could have, and you shouldn't write this, but it's the same thing as x squared minus 9? Yeah, and you might think, why on earth would I do this? I promise there's a reason. I want you guys to, if possible, use the shortcut or grouping to factor this one. Once you have an answer for that, and you give me 2 factors, I'll let you move on to part B. Cool. Start working A. I'm going to write B up here as well. So let's see here. Cool. Talk it out. I'm not starting. I'm just pausing. So there's nothing to solve here, but you are going to factor. No, you're good. And so the language difference there. Now, coincidentally, what is the leading coefficient here? What's the number in front of x squared? And why would I care that it's a 1? There's a shortcut. So check it out. 1 times negative 9 is negative 9. I'm going to skip ahead. It's 3 and negative 3, right? So I think that we get an x and an x in the front. One of them is a plus 3. The other one is a minus 3. Okay, this one, kind of gross right now. 20 seconds. Check this. We got it. What goes into both? 2 leaves behind x squared plus 0x minus 16. Can you guys find factors of negative 16 to add up to 0? 4 and negative 4. Do we leave the 2 behind?
No.
Nope. It comes along. We get x, and what was one of those numbers? Negative 4, and the other one? Okay, we will probably spend about 2 minutes tomorrow at the start of class to really generalize a rule that we just discovered, because it's super handy to have. There is no additional homework. Tomorrow we will spend like 5 minutes talking about this, and then we'll start chapter 4. If you have not grabbed a piece of candy yet, grab one on your way out. Just one.